We have that. We have that. Oh yeah, so another interesting thing I've learned. So there'll be two angles here, and if there's two angles here, there'll be two angles here. Whew. Okay, so the one we're going to have to chase first, and this is angle chasing, as I said, so we're going to say that the sine of x over 8 is equal to, so even all of this knowledge, when it comes to getting it, you can just use an algorithm to get it. But we've got that extra kind of overview to know that it's true. Because again, 6.5 is the red length here. And that 6.5 is sandwiched in between 8 and 5.14, the altitude. That's cool. So we've got a sine of x over 8 equals sine of 40 over 6.5, giving us an inverse sine of 8 sine 40 degrees over 6.5. Notice how much time you're spending on your pen getting that angle x. You know, not on your calculator. Calculator should only be picked up for the last little bit. So we go inverse sine fraction bar 8 sine 40 down to 6.5. Oh, I have a few things to do here now. I know how long it's going to take me to get there. I have to close the argument plus, and then close the bracket for the fraction. Okay. And that's x, which is very nice because I can store it to the variable letter x on the calculator, which is there. Okay, so it's equal to 52.29 degrees. And this is clearly, I don't have to be too precise about it because this is clearly well out in the middle here. 52.29 degrees is x. So now I'm going to go, okay, I'm kind of sorry I did that, but it's okay. I can go 180 minus, because I could have just used the whole expression for this other angle, but I'm going 180, take 40, and take x. So as long as you're confident that you've plugged that in right, that's one way of doing it. And we're getting that z equals 87.7 degrees. But let's step back for x. And remember, x might have been able to be worth 180 minus x. Okay. Okay, I'm not following you really clear, but you see, the other thing could have happened is this could have been 40. This could have been 127.71 degrees. And then we would have got, that's the answer now. So 180 minus 40 minus the answer. And once that's not negative, it's allowed. So z, so x is equal to 50. No, fine, I forgot to write that down. So x is equal to 42.28 or 180 minus it. I think I had things right, but be so careful to be clear on what you're doing here. Yeah, I forgot to write down, or did I? So, or 127.7. So what you could do is actually, it's getting a bit confusing here. So what you could do is you could break those up into two cases. So I'm just trying to draw it now, and it but should I bother drawing it? These are an angle, so I shouldn't bother. I shouldn't try to draw it to scale. I should just say, look, it is what it is. I'll just go back to my original data and fill in the extra stuff, and I'll go, you can have x, y, z this way, or you can have x, y, z this way, and I won't even care. I won't even try to make it look obtuse. I'll just be a bit silly with it. Okay, and say one of my angles here was 52.29 degrees. My other angle here was 127.7 degrees. So you're free from trying to show it as it is. You're just drawing abstractly. Hang on. Why didn't I go X, Y, Z? Okay. Sorry, now I got a bit messed up there, and I'm not going to record again. I'm just going to leave it roll. So those two are the possible values of angle up here. You've got your 40 degrees still here in both cases. And where's that 8? That 8 is here. And they're asking you to find these two values, which are easily calculated. We can calc now from what's going on. So basically, how can I calculate this? Well, I know this is 6.5. In both cases. In one case it kind of shoots that way, in another case it shoots back this way. So I got a pair there and a pair here. But this pair is kind of empty, so I end up having to fill this in. Oh Lord, 180 minus 40. So I hope that you'll just understand this and then do it afresh, and it'll only take a few minutes to do it fresh. Okay, so my angle here is 87.71. I have probably that written there. And my angle here, what do I need to change? I only need to change to 52.29. Another skill to notice that you do in your problem solving, lots and lots of problem solving, is that, and that's 12.3. So here we go. Side length Z equals side length Z over the sine, because I'm doing that over the sine of 87.71 using the sine rule, is equal to 6.5 over the sine of 40 degrees. So I'll solve that. 6.5 sine 87.71. Close your bracket and then hit your fraction bar, and it forgives you for not having the fraction bar on earlier. Over sine 40. Okay, so you get Z is allowed to be 10.104. Probably don't want that much, correct to one decimal place. 10.1, or we would have had Z equals 12.3 here instead of 87.7. So you see, I'll be able to go back in now and edit into that angle up there. So I'll change the angle 87.71 into 12.3 degrees. Okay, and that does imply there's an obtuse triangle, but I'm not filling it in. It's the 12.3 is another way of saying that it's an obtuse triangle, and I'm getting 2.15. And you know what? That was a really long question, so I'm going to go to the. It's actually one I'm going to check myself. So 16.4, question 6. 16.4, question 6. 10.1 and 2.2. Yeah. Now, where's the 2.2? Yeah, that's the nearest. 2.2. And what are the units? No units, so they're just units. Oh, well, we might have been off camera for a lot of that. Sorry if I was. There we go. Take a good look at it. Pause. Great. It's question 6 done. On to question 7. Don't we just love trigonometry? We do indeed. Suckers for trigonometry. Just keep doing loads and loads and loads of questions. X, Y, and Z. And the angle at X is 54 degrees. YZ equals 12 centimeters. And oh lovely, we have an isosceles triangle. So the other two sides are the same length. What does that tell us? It tells us, and look, you know that 180 minus 54 over 2 is equal to this angle. Another way of doing that is 90 minus half the vertex angle. Okay, but look, who cares about mental maths? Okay, you could go 90 minus 27 if you want, but I'm not going to take a risk. Well, I am. It's going to be 50, 63. Let's be double sure. Fraction bar 180 minus 54 over 2. Now, I haven't even read the question, but it's pretty certain I'm going to need that 63 here and here. Okay, calculate the angle at y, done. And find the length xy, and you just look for your diagram, you're talking about this length. Well, they really mean length z to 1 decimal place. So it'll be z over the sine of 63, which I'll bring up straight away, is equal to a side is equal to 12 over the sine of 54 degrees. Okay, so 12 fraction bar sine 63, no, something went wrong there. Fraction bar 12 times the sine of 63, close down, sine of 54, close bracket, down. Okay, so you get the second answer there. You've already got your 63 degrees, and then you've your 13 to 1 decimal place, 13.2 degrees. Okay, question 8. I don't even care what it says out there. I'm getting my KLM in. KLM, which is isosceles with KM equal to ML, and KL length is 18, and the angle at L is 46. That's a base angle, meaning this is a base angle, and the other angle is 180. And let's just write a general situation here. We have a base, and a vertex angle. So if you're getting the vertex angle, it's equal to 180 minus twice the base angle. So we're going to go 180 minus 2 by 46. 180 minus 2 by 46, okay, is 88 degrees. Okay, so this is 88 degrees. Now they all add up to 180, like they should. Calculate the length km. Correct to 2 decimal places. Okay, so we have 3 angles and a side. So looks like we're going to be using the sine rule. So Km is opposite L, so I'll say that L over the sine of 46 degrees, length over sine, length, always length over sine. Okay, so L is 18, and by the way, it'll be less than 18, okay? Just always think about that sanity check because of the way the angles are. Opposite a smaller angle is less than the side opposite the bigger angle. Pushing on into this calculation now, I have a fraction bar 18 sine 46 over sine 88. Okay, and I'm at the 2 decimal place thing, and I'm getting 12.96. Looking for units, centimeters. Correct to 2 decimal places, done. Okay. Question 9. Vertical tower. Okay, we're moving into more intricate and more compounded triangles, and I'm going to park that now and do that later.